Wolverine's healing factor is the stuff of legend, the ultimate superpower. But what if this fictional power points to real science? To explore that question, we look beneath the surface. Is Wolverine's healing factor just a comic book superpower, or is it a blueprint for the future of medicine? This film asks that question, and then looks at the biology that might make it possible. We begin with how the human body already repairs itself. Then we follow the science that could accelerate those processes. Bone healing follows a predictable, multi-stage process. We'll break it down. Step 1, hematoma formation. Blood vessels rupture and a clot forms. This scaffold starts the repair process. Step 2, cells like fibroblasts and chondroblasts migrate and form a soft callus, a living scaffold that bridges the break. This scaffold stabilizes the site and guides new tissue. Step 3, osteoblasts replace cartilage with mineralized bone, forming a hard callus that restores strength. The structure becomes solid once mineral deposition completes. Step 4, remodeling. Osteoclasts and osteoblasts sculpt the bone back to its original shape and strength. It's a slow, complex process, but it's the biological foundation for any enhanced regeneration. Those 4 stages, hematoma, soft callus, bony callus, remodeling, are nature's way of healing. Scientists aim to speed up and enhance these steps, bringing us closer to Wolverine-like regeneration. He is a figure of legend, Wolverine, the comic book hero known for his astonishing ability to heal. His mutant healing factor lets him recover from almost any injury, making him seem nearly immortal. This fantasy of rapid regeneration taps into our deepest wish, to overcome our own fragility. In reality, healing is slow and often painful. A broken arm means months in a cast. A serious illness can change a life forever. Wolverine offers a glimpse of a world without that vulnerability. But is this just science fiction? Or could there be a scientific truth behind the myth? We may not have a mutant gene, but our bodies do possess a remarkable repair system. It's working inside us all the time, quietly mending the wear and tear of daily life. To see if we could ever heal like Wolverine, we first need to understand how our bodies repair themselves now. The journey from comic book fantasy to scientific reality begins within our own bones. So, let's set aside the fantasy and explore the real science of healing. The answers might surprise you. Imagine breaking your arm. Instantly, your body launches an emergency response. Blood vessels rupture, causing bleeding, an essential first step. This internal bleeding forms a fracture hematoma, a clot that acts as a temporary plug and framework for repair. Immune cells rush in, clearing debris and fighting infection. Swelling and pain signal that your body's repair crew is at work. The hematoma is rich in proteins and growth factors, calling more cells to the site. Within hours, your body has controlled bleeding, cleaned up damage, and laid down a structure for new bone. This is the inflammatory stage, a messy but vital process. Without it, the bone couldn't mend itself. Every step is perfectly orchestrated, a testament to our biological resilience. The process is far more complex and elegant than you might imagine. It's not magic, it's biology at its finest. This is just the beginning of the body's remarkable repair sequence. Next comes the real construction work. Let's see how your body rebuilds what's broken. After the emergency phase, your body builds a soft callus, a temporary, flexible bridge of collagen and cartilage. Fibroblasts and chondroblasts weave a network that stabilizes the fracture, but it's still fragile. This soft callus holds the bone together while stronger materials are prepared. Next, osteoblasts arrive to turn the soft callus into hard bone, depositing minerals like calcium and phosphate. The fracture is now united by a solid, bony bridge. But the job isn't done. Now comes bone remodeling. Osteoclasts break down excess bone, while osteoblasts refine and strengthen the new structure. Over months, the bone regains its original shape and strength. This process is a marvel of natural engineering. Each stage is crucial for full recovery. Our bodies are built to heal, but the process takes time. Could we make it faster? Science is working on it. The natural healing process is impressive but slow. Enter stem cells, the body's master repair kit. Scientists can harvest and concentrate stem cells, injecting them into injuries to speed up healing. Gene therapy is another frontier, editing our cells' instructions to boost repair. Modified viruses deliver new genetic information, telling cells to produce more growth factors or reduce inflammation. These advances could dramatically accelerate bone healing and tissue repair. We're not at Wolverine's level yet, but we're getting closer. The future of healing is being rewritten in the lab. What if we could build new tissues from scratch? That's the promise of bioprinting. Using bio-ink made from living cells, doctors can print custom-fit bone or skin for patients. A CT scan creates a 3D model, and the bioprinter builds a living implant that integrates with the body. This technology could replace complex bone grafts and even print organs in the future. Researchers are already bioprinting skin, cartilage, and blood vessels. The ultimate goal: printing entire organs, ending transplant waiting lists. These breakthroughs move us closer to on-demand body repair. While instant regeneration is still fiction, printing new parts is becoming reality. The future of medicine is being built, layer by layer. Healing like Wolverine is thrilling, but it raises big questions. Who gets access to these advanced treatments? Could they deepen inequality? If injuries become minor setbacks, will people take more risks? How would super healing change our view of life, death, and what it means to be human? Regenerative medicine offers hope to millions, but also challenges our values. As science races ahead, we must decide how to use these powers wisely. The goal isn't just to live longer, but to live better. Ensuring fair access and ethical use will be our greatest challenge. The dream of rapid healing is within reach, but so is the responsibility. The future of healing is up to us. Stem cells are the body's raw material, pluripotent cells that can become many cell types. In therapy, scientists coax stem cells into bone, muscle, or skin, potentially speeding repair. Gene therapy uses vectors to deliver corrective genes, activating or enhancing repair pathways. By switching on dormant genes or adding new instructions, cells can be made to heal faster or differently, an echo of the so-called mutant gene. But these techniques carry risks and ethical concerns. Bioprinting constructs tissues and scaffolds, offering a way to replace or support damaged structures. Combined with cells and gene tools, bioprinted tissue could one day replicate complex repairs. Stem cells, gene editing, and bioprinting form today's regenerative toolkit, approaches that inch science toward the fictional ideal. But as we get closer, new questions arise. Imagine a world where everyone could heal like that. Would eliminating suffering change what it means to be human? Would it create new inequalities? If healing is universal, do we seek immortality? Or do we redefine the goals of medicine? If we could give everyone Wolverine's healing factor, what would that mean for society? Would it eliminate suffering or create new problems? Is immortality the ultimate goal of science? The science is advancing. The questions remain. What would you choose?